In this video, I am going to solve a problem on molecular term symbol. The question is the highest molecular orbitals for an excited electronic configuration of the oxygen molecule are 1 pi G 1 electron, 3 sigma U 1 electron. A possible molecular term symbol for O2 with this configuration is, they are given 4 options: singlet pi, triplet sigma, singlet delta, singlet sigma. Before going to that, let us try to understand the configuration. They have mentioned 1 pi G1, 3 sigma U1. This 1 represents the electron. So this particular molecular orbital has 1 electron, pi G molecular orbital has 1 electron. The G represents whether it has inversion center or not. In the case of gerade, inversion center is available. In the case of ungerade, there is no inversion center. The sigma and pi represent the molecular orbital. Sigma orbital and pi molecular orbital. The electronic configuration of oxygen will be something like this: 1s2, 2s2, 2p4. When you go for the molecular orbital, one oxygen atom and another oxygen atom, they combine to give molecular orbitals. 1s orbital of first oxygen and second oxygen, they will combine to give two molecular orbitals. So here we have 2 electrons, here also we have 2 electrons. This is sigma orbital, this is sigma star orbital. Sigma orbital as gerade, sigma star it is ungerade. Similarly, we have for 2s orbitals also. For simplicity, I skip that. I go for directly to p4. Here we have 3 orbitals. So 3 orbitals from one oxygen and another 3 from another oxygen atom, they combine to give 6 molecular orbitals. In that 3 will be bonding, another 3 will be anti-bonding. In this 3 we get sigma and pi. So you can refer MO theory. There we get like this. In the case of sigma, we have gerade. In the case of pi, it is ungerade. I will explain why do we get that one. Here we have pi anti-bonding. Pi anti-bonding as gerade. Pi anti-bonding orbital has center of inversion, so we get G, gerade. But sigma star, as usual, it doesn't have center of inversion, so we go for U. Now there are 4 electrons here. Similarly, we have 4 electrons here. These electrons has to be filled in these orbitals. I have filled the bonding orbitals with 6 electrons. I have 2 more. Totally there are 8 electrons. Now I have to fill 2 more here. So this is the arrangement of electrons, the molecular orbitals of oxygen. This will be the ground state. But in the problem they have mentioned one electron is in pi G, another one is in sigma U. So I excite this electron to the next level, so I get this configuration. Now how to assign the term symbol? You may be very familiar with term symbol for transition metals. It is given in this format. L 2s plus 1 J. Here it is spin multiplicity. L it is orbital angular momentum. J it is total angular momentum. A similar format is used for molecular orbitals also. Here this L is converted to this. It is lambda. The spin multiplicity is same as transition metals. I am not changing that. 2s plus 1, here also it is 2s plus 1. But instead of J, I go for gerade or ungerade. So this is the general format of molecular term symbol. In the case of electronic term symbol, we calculate L from the L value of the orbital. For example, say it is plus 2, plus 1, 0, minus 1, minus 2. So we go for the filled orbital. So we consider that. So here 2 and 1. So total 3. So like that we calculate. If L value is equal to 0, then we go for S term. If L value is equal to 1, we go for P term. If it is 2, we go for D term. If it is 3, we go for F term. Sorry, it is capital. You may know this one. Here, if lambda value is 0, we go for sigma. If it is 1, we go for pi. If it is 2, we go for delta, and if it is 3, we go for phi. Generally, students get confused between these terms, these symbols, because they are not familiar with this. But there is a correlation between this and this. That is nothing but the symbol lambda. The first letter is here. Here it is sigma. The first letter is S. This is pi. The first letter P. Delta. The first letter it is D. This one it is phi. It is not pi. It is phi. The first letter it is F. So if you correlate between this and this, it will be easy to remember. Now the question is how to calculate the L value. If the electron is in sigma orbital, it may be sigma or sigma star. The L value is equal to 0. If it is in pi orbital, the value may be plus 1 or minus 1. Generally, when you go for the molecular orbital, the pi orbitals are degenerate. So one orbital will get plus 1, another one will get minus 1. So if you know this, you can easily calculate the L value. We come across only sigma molecular orbital and pi molecular orbital. So the question should be asked only from this. Now let's go to the given problem. First, let us try to predict the spin multiplicity. It is very simple. It is given by 2s plus 1. Since there are 2 unpaired electrons, it will be 3. You can go for the calculation also. 2, 1 plus 1 will be 3. Simply, I go for number of unpaired electrons plus 1. So the spin multiplicity will be 3. In the problem, they are given one option with triplet sigma. But we can't say that this is the answer. Let's go for L value also and let us try to predict. What would L value? or lambda value. This will be, for this it is 1 and for this it is 0. The lambda value will be 1. When it is 1, the term is pi. But triplet pi has not been given. In the given options, there is no triplet pi. Instead of that, we have singlet pi. Is there any possibility to get singlet pi? Yes, we have. That is, the pi star orbital the spin of the electron is like this. In sigma star u, the spin is like this. So this spin and this spin gets cancelled. Because of that, the spin multiplicity will be 1. The total spin will be 0. You have to go for the formula. The total spin, it will be 0. So this 1 will be there. So there is possibility to get this. This term symbol may not be the most stable one. The most stable will be triplet pi. In this problem, they have not mentioned about the gerade. But very often it is asked. The gerade can be easily predicted from the configuration itself or the molecular orbital itself. That is, if both the molecular orbitals as gerade, then the final will be gerade. If one has gerade, another one has ungerade, then the final will be ungerade. In this case, gerade and ungerade. So the final should be ungerade. Suppose if you go for 2 ungerade, then the final whatever we get will be gerade. So it is similar to plus into plus, you will get plus, plus into minus, you will get minus, minus into minus, you will get plus. So similar thing you can apply here. Here I have given the configuration of O2 molecules. I need not bother about these filled molecular orbitals. Sigma orbital can accommodate 2 electrons. So all these sigma orbitals has been completely filled. So I need not bother about that. Here we have 2 pi orbitals. So it can accommodate 4 electrons. So this also filled. So I need not bother about this. I have to go for only the pi antibonding which has 2 electrons. There will be 2 molecular orbitals to be like this. I go for only the outermost orbital. So this is pi, this pi star, sigma star, sigma. I have 2 electrons here. Now I have electrons like this. How to give the term symbol? The electrons are in pi orbital. In this, one will get plus 1, another one will get minus 1. You may know for p orbitals we give plus 1, 0, minus 1. The 0 value already we have given for sigma orbital. So we have plus 1 and minus 1. I give that value here. For sigma star it is 0. So plus 1 and minus 1 for these 2 orbitals. So the lambda value will be 0. When it is 0, it is sigma. The term is sigma. But the spin multiplicity can be triplet because we have 2 unpaired electron. Suppose if the direction is opposite direction, then it will be singlet sigma. In this case, we have the electrons like this, but here they are in different molecular orbitals, but they are in opposite direction. We have also another possibility, that is both the electrons are in the same orbital. In such case, we will get like this. The another molecular orbital will be empty. Say the value is +1. Now lambda will be 2. When it is 2, it is delta term, but the spin multiplicity, it will be singlet. So this is how we calculate. If you go through some example, it will be very easy. You have to correlate the symbols with electronic term symbol of transition metals.